we're going to work with another kind of equation which involves rational expressions, and that is we're going to be working with formulas which involve rational expressions, solving for one of the variables in terms of the others. So let's consider the following example, which comes from physics. Suppose that we have F equals G times big M times little m divided by D squared, and suppose that we're asked to solve for G. Well, solving for one variable in terms of the others is no different than what you've already been working with. The only thing is that instead of having definite numbers, we have letters which stand for different values. Now, what we're going to be doing is we want to solve for this G. So in this case, we've only got one term on each side. So what we want to do is to eliminate all of the other variables on this side. Let's do something that we practiced with before. Let's multiply both sides of the equation by the denominator to eliminate the denominator. So we'll have F over D squared times D squared. We're multiplying both sides by D squared, for we still continue to have the equality we have. To solve for that G, that means if we divide both sides by the big M and by the little m, then we will be able to isolate the G on the right hand side. So let's do the same thing to both sides. On the right, the m's disappear, they're canceled out, both the big M and the little m's disappear, and we end up with a plain G, which is equal to F times D squared over big M times little m. And we're done. We've solved for G in terms of the other. Now, let's look at an example from electricity. Suppose we have the following equation. Suppose we have 1 over A equals 1 over B plus 1 over C. And in this case, what we're asked to do is we're asked to solve for B. We're asked to solve for B. The solution would be similar if we were solving for C, of course. But once again, we've got denominators, so let's practice what we've used before, which worked really well, and that is to try to eliminate the denominators by multiplying both sides by the lowest common denominator. And of course, you know by now that the lowest common denominator in this case is going to be the number A times B times C, those denominators. All right, so multiplying the left-hand side by ABC, the A's cancel off, and we end up with a plain BC. Multiplying on the right-hand side, let's go ahead and distribute the A times two terms, which are multiplied by ABC, and if we look at the first one, we could eliminate the B's, and we end up with A times C. For the second one, the C times B. Now let's remember what we need to do, and in this case we're trying to solve for B. And so the when you're solving for a variable is to try to isolate all terms with the variable on one side of the equation. And so let's put the B terms on one side. So let's add a negative AB to both sides. So what we end up with on the left is BC minus. Now, again, if you were solving for x's and you had two terms containing an x, you would factor the x out. In this case, we're solving for b. We will factor the b out. And so we have a b times a coefficient. And you remember from before that we can take both sides of the equation, divide by that coefficient, so that on the left-hand side we'll have a plain b. And we can see off on the left-hand side, and we have succeeded in solving for b in terms of the other variables. So b then is going to be equal to AC over C minus A. Now, one of the things that I should mention is that when you're solving for one variable in terms of the others, be careful. Your answer may be perfectly fine, but it may look a little bit different than the answer in the book. So look and see if your answer is equivalent. With the next example. Suppose for the next example that we have the following. another formula, in this case S equals n over 2 times A plus L multiplied by D. And what we're asked to do is to solve for L. Well, in looking at the formula, you can probably see that this formula, it looks like there are many different ways that we could work in order to solve for that L. And that's why the answers may look different, but they may quantity inside the A plus L, and we could try to get rid of those first. So let's do that. Let's multiply both sides of the equation by, first of all, that 2 to get rid of the fraction. So we'll have 2 times S equals 2 times n over 2 times the quantity A plus L times D. Well, now on the right-hand side, we have gotten rid of the 2, and so we're fine. So on the right-hand side, now we have an A times the quantity A plus L times D equals 2S on the left. Well, we could try to be a little more efficient, and we notice that on the right-hand side, we'd like to get rid of both the N and the D. So now let's divide that right-hand side at once. Well, on the right-hand side, the N's cancel off, the D's cancel off, 2S over N D. Okay. Now, we're solving for L, so let's keep that in mind. So all we need to do now is the equation, and we have the problem solved. On the right-hand side, we're going to have a plain L. On the left-hand side, we're going to have 2S over N times D minus A. So that is one solution to this problem. Okay? But what if we had N over 2 times A plus L times D? Suppose that we had gone ahead and multiplied out these two coefficients right here by each of the terms inside. And so we would have A times N over 2 times D. Solve for L. So let's get rid of this term over here by adding the negative of this to both sides. So let's write that as S minus A and D over 2, and that equals L times N over 2 times D. Okay, now at this point, let's get rid of this 2 by multiplying both sides of the equation by 2. So we'll have 2 times the quantity S minus A and D over 2 equals N over 2 times D. On the right-hand side, the 2's do cancel off, and we end up with L times N times D. On the left-hand side, if we pull the 2 through, we're going to have 2S minus 2 times the quantity A and D over 2. Okay. Well, you notice now that on the left-hand side, we could cancel this. And at this point, we are trying to solve for the L, so we'll divide both sides of the equation by ND. Okay. And so finally, we end up with our solution for L, which is L on the right-hand side, since the other factors cancel off, equals 2S minus A and D divided by ND. Now, let's compare this solution to the other solution we had obtained working. Two perfectly good solutions for the problem, because if I were to get a common denominator of ND for the left-hand side, I would have the 2S over here, and I would have to multiply the numerator and denominator by ND over here. For ND, I would have exactly the same thing. So what I'm trying to say is your answer may look a little bit different than the answer that the book has, but it may be perfectly equivalent. So check your work, see if you worked it the right way, and see